left for community discussion related to the last two talks. In particular, if there's anything that people would like to talk about that might end up being a finding, for the meeting, that'd be good to mention. And Clive is approaching the microphone.
Yeah, Clive Neal, Notre Dame. I just want to thank Steve, Ben, Jake. This is a whole new world compared to a year ago, where we have a lot more opportunities. And just want to give you guys a big thank you for your hard work, and even Ben. So, thank you very much.
Anna Hurley, APL. So yesterday we were talking about decadal priorities, and one thing that came up was that a lot of the science we want to do is accomplished well by having campaigns. And so is that something that we could do through the CLIPS, put in a proposal to fly multiple instruments to multiple locations and have it in one proposal, have that be the science?
That's a good question. I certainly would entertain doing something like that, because again, the whole idea of CLIPS is to provide multiple opportunities. And as we start building up the successes, and it provides more opportunities to our CLIPS providers as well, the more task orders we can put out. The more, they'll take them. So yeah, that's something that would be a good problem to have. And so more challenges for Chris and his team at JSC, but yes, definitely entertain that. And by the way, I got to thank Chris and his CLIPS team at JSC. Clive, thank you for the shout out, but certainly in coordination with Chris and his team at JSC, the CLIPS project office, they're doing a phenomenal job. So thanks.
I think maybe a finding is something along the lines, Mark Robinson, ASU. Yep. Is along the lines of coming up with a set of realistic goals and objectives for a lunar prospecting strategy. Steve talked about a couple of very interesting new missions that were recently selected. And, obviously those are going to make good advances, but, the key thing is to get the most out of this ISRU demonstration missions, is make sure that we understand, the ore body, what is the grade and tonnage, and then we can go make the best selection in terms of what to put in that hopper. Maybe not on the first try because we may not have enough accessibility, but down the road on the second or third try. And I don't see right now a really coherent prospecting program. I think there's a lot of pieces there. So maybe we're somewhere between 40 and 80% of the way there. And we should identify what's missing and how we can put these all together so they feed forward into making the best decisions on how we're going to utilize these resources, if there actually is a resource.
Sounds good.
That's my thought. Yeah.
Brad Jolliffe, Washington University. So this is for Steve, but also a comment. I think Mark will actually talk about this tomorrow morning. In 2007, we had a workshop associated with the Constellation Program, the Tempe workshop. And the question for Steve is, I think the name of the title is Science Strategy of the Moon, but on one of the charts it said Science Strategy at the Moon, which is interesting because there's lots of science. So my question really is, does that science document talk about all of the other things one can do, not just on the moon, but at the moon? And that would include helio, astro, Earth, as well as planetary.
Yes. and that's why it is at the moon, because it's not just the surface. It could be using Gateway. It's that cross-discipline science that I mentioned. So yeah, that's the intent, is to be broad. Yep.
So in the decadal, Jonathan Weinberg, Ball Aerospace, in the decadal, we often talk about enabling technologies that need to be developed for to achieve science goals for certain missions. And I just kind of want to extend that and say, just sort of enabling infrastructures and enabling CLIPS capabilities, because I think that I mean, if I were a CLIPS provider, I would want to know what the science community wants in terms of technology development, infrastructure, and capabilities, because by extension, then NASA would have a larger pool of things to choose from. And so I just wanted to say, you know, Steve, you're talking about we want to get capabilities down there, and I think in either in a formal or informal interaction, I think working with the science communities to see what capabilities are of critical importance, I think would be a good step, and it'd be beneficial for both the CLIPS providers and the NASA scientists.
This cross-discipline science that is beginning to bubble up really nicely is very exciting and also a little scary. Let me talk to the scary part first, and then let's come back to the really exciting part. The scary part is we've been through this many times, and the lunar science community is very sensitive, going back to Apollo, where lunar science was viewed as sort of the crumbs that the big missions, the Apollo missions, are going to solve everything, so the science doesn't have to be put into lunar science, because the big mission, the Apollo mission, is going to take care of it. And the science can be put elsewhere, to Mars and the outer solar system, et cetera. So we're sensitive that we don't get our due, because we're seen as part of, that we will be taken care of by this larger program. Okay, fast forward a couple of decades, and here we are, and we've got some really exciting things happening. And this concept of cross-discipline between the science directorate and the HEO directorate is really exciting, very positive in terms of being able to join together to do the kinds of things that we're excited on pressing forward with. And I just hope that this can be discussed in a way that doesn't jeopardize it one place or the other. That by joining forces, we can really do a lot. It's just we're a little sensitive from some of the history where we don't get the science that we expect because it's going to be done over there. And somehow, let's make it happen this time, because it really is exciting that we can be thinking of this joint kind of capabilities. And I know you guys are thinking of that, but let's just make sure, I'm sure everyone in this room would like to see it happen. But there is this tension that the rest of the science community will say, well, okay, lunar science, we don't have to worry about them. It'll happen in the other program. So let's make sure that this joint kind of operation really brings forward the strengths and doesn't fall back into what happened decades ago, where we had to struggle to make lunar science visible.
Great, thank you. And I just wanted to close out this discussion section with a comment that kind of brings us back to what the discussion with Greg a little bit earlier was related to samples. And it seems like a lot of the current discussion in that area is being capability driven, and definitely high grading and choosing better samples, and in advance saying we want that rock from the science community is good. But I'm wondering if it would be useful to the Artemis community if LEAG potentially had a specific action team that would stand up and do a forward model and say, this is how much sample we specifically need to address these science questions. And this is similar to what we recently did on the discovery proposal. We went by gram, the analysis that we would need in order to address science questions. And there might be less of a disconnect between the capability and the requirements if that's done.
Is it Clive Neal, Notre Dame. CAPTEM LEAG did a joint specific action team study on this back in 2010. It's available on the LEAG website. And some of the masses, Greg, are quite large. But as I say, I'm looking at this as a beginning. It is more than Apollo 11 that is tended to come back. I'm expecting it to evolve, and so as risk is retired. But again, this study was done. It may need to be dusted off to see if it's still valid, but that is there. And if you start putting humans down on the surface of the moon, more humans for longer times, and we know that Apollo 17 brought back 110.5 kilos, then that's a lot of samples. So what Mark says is important in terms of having the right training for the astronauts to be able to high grade those samples and bring the top quality ones back. And again, that is a great problem to have. But I think the study's been done.
Okay.
And the answer is, yeah, you're going to need more than 110 kilos. So.
Dean at Aerospace. Along those same lines, in another incarnation of my life, I wrote a risk in Constellation for, and believe it or not, for Orion to have more sample capability. So this is not a new problem. And it looked at everything. And I'm happy to make that available because there's no reason we need to renew that. And it was based on discussions with Chip Shearer and Clive and Captem that we got the numbers derived, and it was 225 kilograms, by the way, was what we came up with inclusive. So now that has to be revisited, but the bottom line is we've done this, and I don't think we need to do it again. What we need to do is look at what we did and modify it as appropriate. So
great. Yeah. All right, thank you. Well, let's thank our speakers again. And we'll break for lunch now, reconvening at 1 p.m.